Hey, Granite, hello. Let's go turn this down here. Sorry. Hey, how you been? That's okay. Hey, man, it's all good. You've been sitting and chilling. That's all good, bro. Yeah, switch to the cam here. What you been up to, Granite? How you been? Even if you're not around Twitch, it's not a problem. I'm still here. I'm teaching classes for this summer. That's what I've been doing. What you been up to, my friend? What has been going on? How have you been doing? I guess that's what I'll ask. Trying to wrap your head around YouTube and TikTok algorithms work. A video of mine blows up where I literally say a singular word, but something I put time and effort in gets less than 20 views. Oh, well, I don't know. What word did you say? If I may ask. It sounds like you literally said a singular word. I'm like, what word did you say? Apparently it was good enough for people to watch. How many people watched your video, out of curiosity? I mean, one thing that really helps the YouTube algorithm that I think I've seen on videos before is just having people leave comments or something. And then, of course, smashing the like button and all that stuff, you know. Subscribe, hit the bell notification icon, you know. Yeah, the more people who comment on your video, the more the algorithm works in your favor. Nearly 500 views in under an hour, wow. Well, I guess, just if you have people encourage people to write a comment or something like that, if you ask them an open-ended question or something like that, it says, hey, tell me what you think, tell me what your thoughts are, something like that. Yeah, just send it through the message, I mean, that's fine. It's just like, as long as it's clean or something like that, and, they have, it's not geared to kids, that doesn't get, I don't think that gets put on the recommended list anymore. At least I don't think so. I forget, they had that whole thing with the kids thing, so. But comments are the way to be. Alright, I'm gonna watch this.
Dropped my gamer headset.
Alright, let me hang on a second. Alright, give me just a second. I gotta listen to this off stream. Hang on. Alright, I'm back. So silly. I just watched it. That was so silly. I think people try a little bit too hard on TikTok. Not you, I'm saying. It's just funny, that's all. Hey, Lee Wen, how you doing? How we doing today, Lee Wen? I hope you're doing well. What you been up to today? Yeah, granted, I think it's all comes down to comments and then just kind of getting you just kind of making it as meme worthy as possible. You know. Good, good. I think I might make an adjustment for the class, so well, let's see how things go. Yeah. So yeah. There we go. For some reason that went down. All right, there we go. Perfect. Okay. Alrighty. Well, thanks for the posture check. Thanks for the hydration. Hey, thank you, Granite. That's very kind of you, my friend. That's very kind of you. Super, super kind. I always appreciate you coming into the stream and just having a nice time. That's all I want. All I want from anybody in the stream, to be honest. So, doesn't have to be a super big deal. It's just like, here it is. There it is. All right. We have a few people here. Yeah, get going because it is time to do this. Could you show me how to solve the question using the calculator? Yeah, I have to take a look at that there again. A second. Yeah, can I show you that after class, Lee Wen? I can totally show you that there. Any math knowledge used for me? I'm doing GCSE mocks. Okay. Oh, okay, I got you. Well, we're doing a little bit of derivatives and calculus today, so hopefully it'll be helpful. Lee Wen, can I show that to you after class? I can definitely show you on the calculator there how to do that. It's really not too bad though. If you're cool with that, I'll stick around after class and I'll show you how to do that on the calculator. All right, cool. All right, let's do some intros. Let's get started and we'll get going here. All right, let's do it. Okay, let's get started today. Welcome back to Tuesday. All right, so we're going to pick up where we left off last time. Last time we finished off here chapter 3. We did implicit differentiation. All right, we got that stuff done. I think there was a couple of problems that I didn't get to do, so I'm going to probably do those first, and then we'll move into chapter 4 here, and we'll get going with that. So, I'm going to ask you guys a quick question here, actually, from last time, and this is something that may be helpful or maybe not helpful. I don't know. Okay, but I'm gonna get just a small little poll here. How many people liked me doing some of the homework problems as examples? Was that pretty helpful for you to kind of get to know how to do for practice and whatnot? Let me go. Let me know what you guys think if I about that. So you think that we do some we do the examples, and instead of the examples maybe from the book, we try some of the homework problems as the examples instead? Is that something that you would like me to go ahead and give a try? I'm gonna leave it up to you to see what you guys tell me. So what do you guys think? That would help. Okay. All right, so Nick said that would help. I don't know what others think here. Emma thinks okay that way would be good. Okay. Um, I don't know what you think about that, Lee Wen. You wanna Do you think that that's a good idea or not? But it's gonna probably If you guys think that's a good idea, I'm gonna roll with it. Okay, fine. All right, so you guys think that's a good idea? That's okay. We're gonna roll with that idea. Perfect. Okay, no problem with that. I wanted to get your opinion first before I did anything else. But I feel that if we need to take a shift in about how to approach certain problems, then let's do a certain shift here. So maybe I kind of felt like the past couple weeks and 2.5 weeks. The first 2.5 weeks of class, you guys have some of your feedback there. You felt a little lost at times, and you felt a little like saying, "Hey, I'm not sure about a couple of things here." I'm like, okay, you know what? Let's dial it back a bit. And I was kind of thinking about that yesterday, and I was like, okay, well, that's why I kind of tried some of the problems here yesterday. I'm like, oh, well, let's give it a go, and looks like that happens to be the case. All right. In any case, let's go to the big board. Let's start off with a couple of problems here that we didn't get around to yesterday, and we'll go ahead and take a look at it and do it together. All right. All right, so the first one here is going to be number 7 here from the homework. Again, this says find the equation of a tangent line to the graph of function f defined by the following equation at the indicated point. So they give us x minus y minus 1 to the third power is equal to x, and they give us a point here of 1 comma minus 1. Okay, so let's go ahead and do this out here. So we have x minus y minus 1 to the third equals x. Now all we're going to do here is simply go ahead and remember this was for the dy over dx. So anytime we take the derivative of y, we're just going to slap a dy over dx next to that derivative. That's essentially what we're going to be doing. The way we're going to approach this is we're going to approach the chain rule here. Take the 3, bring it out to the left. Remember inside here. Imagine having points. There you go. So we have x minus y minus 1 squared. Okay, so again, doing the outside, and then we do the inside. So the inside here, the derivative of x is 1. The derivative of a y is 1, but we have to have a dy over dx next to it. All right, and minus 1 here, well, that's just 0, so that's fine. So we have 1 minus dy over dx. All right. And this is going to equal 1 because that's the derivative of x that we have here. Okay, so what we want to do here is solve for dy over dx, but in actuality, if we want to solve for dy over dx with the point that's given here, well, here's the nice part. The nice part about this is at least you could go ahead and plug in the values in for x and y and directly find dy over dx like a regular kind of mathy type of algebraic type of problem. So let's take a look at what happens. We're going to have x is equal to 1 and y is equal to minus 1. This is from the point that we're given here, the 1 comma minus 1. Because what we're going to do here is basically say, okay, hey, what's the slope of this tangent line? Okay, that's essentially what we're trying to find. So let's plug it in. So we get 3 times 1 minus a negative 1 minus 1 quantity squared times 1 minus dy over dx, because we don't know what that is just yet. We'll figure that out here in just a moment, equals 1. Okay, so let's clean some stuff up here. So we get 3 times 1 minus negative 1 is going to be 2. That's 1 plus 1, 2. Minus 1 is 1, so this becomes 1 squared. And this is 1 minus dy over dx equals 1. All right. So fortunately for us here, 1 squared is really easy. That's just 1, so nothing much going on there. That leaves us with 3. 1 minus dy over dx equals 1. All right. So far, so good. All right. Let's take a look at what we have to do next here. Next, as part of this problem, if we're going to solve for dy over dx, we're going to just divide by 3 on both sides. Again, we're just trying to get dy over dx by itself. So Here on the left-hand side, we get 1 minus dy over dx equals 1/3. Then we'll subtract by 1 on both sides. So we get negative dy over dx equals negative 2/3. All right, and then we go ahead and divide by negative 1, because that's that negative on the outside there. And if we divide by negative 1, finally we get dy over dx here, doing some manipulations, is equal to positive 2/3. Okay, so we did a little bit of algebra there. Nothing too fancy, but there we go. We got it. 2/3 is going to be the slope of our tangent line. Okay. So before we keep going here, are there any questions about that? Everybody good with that, I hope? Any questions at all? Yeah, I just hope that that was clear about how we found that value. Okay, so what were we going to do next? Well, if we're going to find the equation of a tangent line, all right, let's talk about that. If we're going to find the equation of a tangent line, we're going to go ahead and use a certain something, that being the point slope formula. Now, the point slope formula here is going to be y minus y1 equals m times x minus x1. So this is the point slope formula here that we're going to use. So we have the slope. We're also given a point here of 1 comma minus 1. Okay. Again, this will be our x1 and this will be our y1. So all we're going to do here is plug in a value in for x1, plug in a value for y1, and plug in the value for the slope here, which is equal to m. All right. And so let's see what we get here. So we get y minus y1, y minus negative 1 equals 2/3 x minus x1, which is 1. Let's clean this up a bit. So we get y plus 1 equals, here we get 2/3 x minus 1. Now again, the goal here, if you take a look back at the problem, let's take a look back at the problem here really quickly, and I'll come back to this. Is that they ask us for y equals something, okay? So they want like y equals mx plus b. That's why we're going through this process here. All right, so we need to solve for y here after we distribute and do all those sort of things. So that's the expectation here in this problem. So we have 2/3 x minus 2/3. Then we'll subtract 1. We finally get a final answer here of y is equal to 2/3 x minus 5/3. That's our final answer for this problem. All right, cool. All right, any questions about that? I hope that made a lot more sense now. Hopefully with doing these homework problems, will be a tad bit easier to do. So, and again, you can enter this stuff in. You know, yeah, 2/3 x minus fraction here, 5/3. And that's correct. So the other ones are wrong because I didn't fill them in, but yeah, you get the idea. All right, so you can see we got the correct answer for that one. Nice. Okay, let's try the last one. All right. So the last one, number 9, says effect of price on demand for tires. So suppose the quantity demanded weekly of Super Titan radial tires is related to its unit price by the equation P plus X squared is equal to 361, where P is measured in dollars and X is measured in units of 1,000. How fast is the quantity demanded weekly changing when X is equal to 13, P equals 192? Okay, and the price per tire is increasing at the rate of $2 per week. Okay, so this looks a little bit confusing, but in reality, it's really not as bad as it may seem. Okay, so we want to see how fast this quantity is essentially changing. All right, let's find out. And I need to go ahead and that over. Okay, it's over to the side. Okay, so we're given here P plus X squared equals 361. All right, this is our guy here. Let's see, the quantity demanded. All right, that's fine. Okay, so the thing that we want to do here specifically is to figure out exactly how many tires how fast is this quantity going to change after X period of time. So in this instance, if we take the derivative of this, let's see what we get here. Now, if we take P here specifically, the derivative of P here is going to be 1. However, because we take the derivative of P with respect to X, we're going to have 1 times dP over dx. All right, so dP over dx basically is representing the price that is essentially increasing with respect to X, the price per tire. So that's essentially what we have here in this case. And this is equal to 2X equals 0. Let's see if I have that right. Let me check one thing here. If I have that backwards or not, I hope not. I hope I don't have that backwards. That'd be pretty bad. I don't believe. Make sure about that. For differentials. Unless I gotta multiply by x, in which case then it makes sense. Just a moment. Check. If I have to multiply by x again, then that's probably what I Okay, all right. That's probably what I need to do there then. Okay. Hey, Gemma, how's it going? All right, let me go back here for just a moment. Make one change to this. I was gonna say, I'm like, this doesn't make a whole lot of sense if we don't met this out. But question is, if I have to multiply by x again, do I have to do anything else besides that? Otherwise, it's just really, really easy. I just have to plug in a number. So I bet I'm overthinking this again. I did this before, and I'm like, to put it short, I couldn't be more upset if I tried. Uh-oh. Why are we upset? What's wrong? What have I done? I probably have done something. Knowing me, I probably just did something that probably was dumb. Well, then again, I do a lot of things that are pretty dumb. So, I mean, I ain't gonna lie. But, all right. All right. Do I get that? I gotta think about this one here. Just stuff going in your personal life. Oh, that's a bummer. That's a bummer. Hmm. I need to think about this last example here really quick. All right. Hang on a sec. I'm probably missing something here off the top of my head. But when in doubt to do stupid things. Let's see here. That's a solution. That's just I'm probably doing in my head just really really dumb. Really dumb here. Like I said, sometimes I'll get stumped too. So like that absolutely doesn't even help me. All right. Wonderful. Pointless. Also pointless. Give me less pointless garbage.
Price that's changing.
Blah blah blah. And do I have to multiply by x? Yes, I know this. Oh, okay. That's what you want me to do. All right. All right. All right. All right. I got you. All right. That's fine then. Got it. Yeah, okay. Sorry about that, everybody. All right. Let me rephrase what we have to do here for this one. Okay. So what's the trick behind this problem? And I totally forgot it. That's why I actually forgot about this one here. But the trick behind this problem is to take the derivative with respect to t. Totally forgot. So t here is going to be time. All right. So let me go ahead and point this out here because I missed this myself. And it's always important to, if I screw up, then it's important for you guys to see it as well. If you take a look here at the problem, we have a time here. This time frame is actually referring to per week, okay? And this will be important because we're going to take the derivative with respect to time here specifically. That means that the scope of this problem will definitively change. At the end of the day, we're going to have dp over dt here is going to be our guy. Okay, again, dt here because we take the derivative with respect to time. And the derivative of p here happens to be just 1. All right, then we take the derivative of x squared, which is 2x. But because we take the derivative with respect to time, we're going to put dx over dt here. All right, And that's going to equal 361. All right. Oh, not 361 equals to 0. What am I doing? That was a lot of poop. Make sure we have that. Okay. Need to make sure about see if I'm not messing that up. Yeah, that should be fine. Okay. All right. So what we want to do here specifically is we want to go ahead and fill in what dp over dt is. Now dp over dt, why is it 2x dx dt and not just 2 dx? Because we have specifically here we have x squared. Remember, Elizabeth? So the derivative of x squared is 2x. All right. So you don't forget the x has to still be there, right? We're just doing the regular derivative of x squared. And then we're putting a dx over dt next to it. Just like if we did dy over dx, because we took the derivative of y with respect to x. We're doing the same thing here. Does that make sense for that, Elizabeth? Yeah. Look, it was a dub moment for me too, okay? I totally forgot time was actually a thing in this one. So it's on me. Don't blame yourself. It's on me. All right. Now our goal here, what's our goal? Let's talk about our goal. Our goal here is to solve for dx over dt. Because what we are given here specifically is we are given dp over dt. Remember, the price per tire is increasing at a rate of $2 a week. So we're given here dp over dt here is equal to 2. We're also given an x value here, which is equal to 13. So we can start filling in the gaps here in this equation, and then seeing if we do a little bit of algebra to get dp over dx over dt, pardon me, and we're going to get our final result there. So that's essentially what we're going to be doing here for this problem. So let's go ahead and see what we get. All right. So in this case here, in this case here, we're going to take a dp over dt, which is 2, plus 2 times x, which is 13. Dx over dt equals 0. Okay. So now what we're going to have here specifically is we're going to go ahead and have 2 here plus 26 dx dt equals 0. Let's go ahead and play around with some numbers here. We'll subtract 2 on both sides. So we have 26 dx dt equals minus 2. We'll divide by 26. So here we get negative 1/13. And if we do the decimal out here, let's do the decimal. So dx over dt here and if we do the decimal out on the calculator, we're going to get, let's just take a gander. We're going to get negative 0.0769. 0.769. Okay. So this is what we get here. Now, the question really comes down to this. We got dx over dt, right? However, be very careful about this, okay? So one thing to keep in mind here in regards to this is that we need to take one extra step here in this instance for this particular problem. And the reason is it's actually in the wording of the problem itself. P is measured in dollars, X is measured in units of 1,000. Okay, so we did it in terms of thousands of units. So we need to multiply this 0.0769. We need to multiply that by 1,000 to get our final result. So let's go ahead and see what we get here in this case. So here we're going to get 76.9, negative 76.9. Now, I think they might want it to the nearest tires. So either they want minus 76 or minus 77. We'll try minus 77 first and see if it happens to like that. So let's take a gander here and see what we're working with. So, let's try minus 77. See if it likes that first. Yes, I know. All right, so it liked minus 77. All right, and there we have it. We got it, and there we go. Yeah, I can check. I'll check it when I can, Gemma. I promise. All right, so minus 77 here, they want us to round up, is going to be our final answer for that problem. All right, sorry about that. I totally forgot it was taken with respect to time, but once we got that down, the rest of it was pretty clinical. All right. Any questions about that example? No. Okay. Don't think so. All right. Okay. Let me ask Nick. Nick, was that okay? I hope so. Just making sure that if that made if that was pretty clear. If you have any questions, just let me know. Okay. Okay. Yeah, you just got to redo it different numbers, but it's the same premise. All right. Great. Okay. Yeah, your problem will have different numbers, but same steps. I promise you. Okay. All right. Let's focus on the next section here. All right. So the next section here, let's talk about that. Come back to this dude. This dude is now done. We're now going to be focusing on chapter 4 here. All right. So let's talk about chapter 4. We have a lot of things to talk about here in chapter 4. A lot of things to do, right? A lot of the stuff that I'm going to be talking about here today is going to be pretty basic in terms of its approach. Um, you'll notice one thing about the next two sections for sure is that a lot of steps are going to be repeated, a lot of them. All right, so you'll be like, oh, we're doing the same thing again. Ah, we're doing the same thing again. Ah, we're doing the same thing again, and you wouldn't be wrong. All right, so I'm not saying that we're not. We definitely are. All right, so I'm just letting you know now. Be like, oh, where did all this come from? Be like, oh no, this definitely came from somewhere. I promise you. All right. Anywho, okay. So let's take a good look here at section 4.1. All right. First and foremost, number one, question one: what is an increasing, decreasing constant function? Okay. Well, this is the by far. Have a good one, Gemma. We'll see you later. We can talk later, okay? I promise. All right. Increasing here is a graph that goes up like this. There you go. Graph goes up, it's increasing. I know this is the most devastating thing you've ever learned in your life, but increasing graph goes up, it's amazing. Okay. Decreasing the graph goes down. Man, decreasing, completely devastating. It's the hardest thing you'll learn in this class, 100%. And this is where they pay me the big bucks. What's a constant graph? Constant graph is it stays flat or the same. That's where I make all my money. Okay, is I teach you complicated topics such as question number one. Okay. The whole semester will be like this, okay? The most hardest questions ever. Okay. All right. So, yes, we'll move forward. All right. In any case, let's take a look at question number 2 here, and let's talk about what we're doing with increasing, decreasing, and constant functions. So what we want to be able to determine here in this section is to determine the intervals over where a function is increasing or decreasing. Okay? Now, in order for us to do that here, what we're going to do is we're going to do the first derivative test here. All right? And you'll notice a lot of these times, actually, I wonder if I have, oh, I guess I don't have enough space for that. That's kind of my fault. I thought I did. Let me try and move that step 5 on there. That's kind of important. All right. Certain parts are very important for this process. So first derivative test here. All right, so let's go over this carefully. Okay, so step number 1 here is to find the derivative. Then we're going to set the derivative equal to 0 and solve for x, i.e. find the zeros of the derivative. Then we'll do steps 3 and 4 here. We'll start chopping up a number line. We're going to be making a chart here, and we'll be going over that in a little bit more detail. Now, the reason why I'm kind of stopping here for just a moment is not to skirt the entirety of the question, of course. Of course not. I want to go over this slow here so that way you'll be able to understand exactly what we're going to be working with. And as such, because it was requested already, we're going to go over some assignments. So let's go over an assignment preview. Some of these are already visual questions, but let's go over one here that we immediately see. All right, so I want to try question 5 because it's a little bit more involved, but not by a ton, okay? So let's take f of x is equal to x squared minus 7x, and we're going to find out where this function is increasing and where this function is decreasing. We're going to be able to find those intervals. Okay, so x squared minus 7x. Let's bring that up on the paint tool here. All right. Okay, now that we have that written down, I want to go ahead and take a look here back at our steps here on our guy. Go ahead and do that. There we are. Okay, let's go through each step here very carefully. Okay, let's do step number 1. Step number 1 is to find that first derivative. Let's find that first derivative. Okay, so what's the derivative here of x squared minus 7x? What is the derivative? Let's just go with that. Something simple. 2x minus 7. Perfect. That's right. Okay, easy peasy. So we're done with step 1. Just do 2x minus 7. Seems simple enough. No problemo. All right, so far so good. Great. All right. Next, what we're going to do next here in step number 2 is to go ahead and we're going to set the first derivative here equal to 0. So all I would like you to do is set 2x minus 7 equal to 0, and we're just going to solve for x. Again, there could be multiple ways to solve for x. We may not get an equation this simple. Maybe you'll have to do factoring, maybe quadratic formula, whatever. There's a lot of different ways, a lot of different things that we could see. But here we have a pretty simple equation. So we'll just go ahead and immediately solve for this. We'll add 7 to both sides here. Simple enough. Okay, so we get 2x equals positive 7 divided by 2. And okay, this is what we get here for the 0 of, in this case, we've just found one x value. X is equal to 7 over 2. Okay. All right. So everybody probably could see where we're going with this. All right. All right. So no problem so far. Pretty simple to get 7 over 2. Easy peasy lemon squeezy. Now the real question comes about with what happens after that. Now, one of the things I love to do here is to make things visual in these circumstances. And this is exactly why I have steps 3 and 4 is to make things significantly easier for you to visualize exactly what we're working with. Okay, so I like doing it this way because it was always probably one of the easiest methods that I know I could constantly get it right every single time. So step number 3, let's talk about what this says here. Step number 3 says to chop up a number line using the zeros you found in step 2 to determine the intervals to test over. Now you're probably saying, chop up a number line? What do you mean? Well, let's chop up a number line here. Let's say this is a number line. Say we start off at minus infinity, go up to positive infinity, and we also have a 0 here of 7/2. So if we're chopping up a number line here, all right, we're just going to put parentheses, again, just doing integral notation here. I put a parenthesis next to negative infinity, put a parenthesis next to positive infinity, and we'll go ahead and put parentheses here at 7/2 since that was equal to 0. Now, as you can see here physically, on step number 3, when we chop up the number line with our respective 0 or zeros, you can physically see the intervals that we're going to be specifically looking at when we are testing it with this process. And as you see here, we're going to start making a small little table here in the very next step. Let's start doing that right now. So the next step here is to go ahead and take a test point in each interval of your choice and plug it into f prime of x to determine if the answer is plus or minus. Now, basically, what am I saying here in this case? Well, we're going to be making a small little chart, all right? So we're going to have the intervals here. All right, so the interval here you see we're going to have from negative infinity to 7/2. And we have 7/2 positive infinity. We're just going to take a test point here in each interval. That'll be the next column of this chart. And all we care about is plus or minus, okay? So let's talk about this next step here in step 4. Take a test point in each interval of your choice and plug it into the derivative. Okay, stop there for just a moment. All right, so let's first take a test point in each interval. So I want you guys to help me out here. You guys choose. What do you guys want? Do you pick a number here between negative infinity and 7/2? 7/2 is like 3.5. So let's pick a number here between negative infinity and 7/2. Just pick any random number, and we'll work with that. All right, -4. That's fine. Okay. Now let's pick any other random number here between 7/2 and positive infinity. So pick a random number here between 7/2 and positive infinity for our test point. 2, unfortunately, is not going to be it, Elizabeth, because 7/2 is 3.5. So it has to be a number between 3.5 and infinity. Be very careful about that, by the way. Okay, so make sure that you, yeah, be careful about that. Okay, you can pick any number, just make sure it's in the interval. Okay, it has to be in the interval. That's important. Okay. Okay, so 4, 6, that would work perfectly fine. Okay, fine. So here we have plus, all right. So all we're going to do here specifically is we're just going to plug in -4 into the derivative. Okay, so notice here, we're going to plug in -4 into the derivative. Now again, I don't care what the answer is. The only thing I care about is the sign of the answer. So I put that here. You don't care about the number, just the sign of the number, and we're going to just make a note of it in our chart. Okay, so if I put in -4 into our derivative, which is what we have here from step 1, do I get a positive or do I get a negative answer? Again, what's a good way to check? you can enter this into your calculator if you like. So let's at least bring out the calculator for this. Calculations for this are rather fast, so, but still. Okay, so a good way to kind of do this out is you take your derivative here of 2x minus 7. This one's pretty fast here, so we'll just enter it in. 2 times minus 4 minus 7. And it should be pretty clear, but again, so we get negative whatever, negative 15. So the answer here will be negative, okay? So that's all I care about. I don't care if it's 15. I only care that it's negative, all right? And now I'll do the same thing for 4. So 2 times 4 minus 7 will be positive, in the case of positive 1, but it doesn't matter. So here I'm going to put a plus, all right? Okay, any questions about that? Got one more step to go, but it's a very easy step. But I want to be sure that everybody understands where we got this chart from here first and foremost. No? Now here's the nice part about this process. Let's talk about the nice part about this process. Let's go back to our notes here for a moment. So the nice part about this process here is, how do we know we're increasing, decreasing, or constant? Well, let's take a look at our plus minus chart. So the denominator, wait, what's the denominator? You mean deno? Is that what you mean? There's no denominator here. So Nick, I just used the derivative here. So again, if you read the step here, we plug it into the derivative. So that first derivative there. If that's, yeah, so all I did here specifically was I did 2 times negative 4 minus 7. So I took this negative 4 and plugged it in for that x. And I did 2 times 4 minus 7. That if that was the question there, because I was a little confused about what your question was. I saw the 7 and the 2 and assumed it's from the Oh. No, 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 no. No. That was from, I'm using the derivative here. So read that step clip carefully there, Nick, okay? So make sure you write that down. If you haven't written down, then at least take a screenshot. Make sure you know that basically what I'm saying is that you plug it into the derivative. So make sure you, if you need to, just underline it if you need to. You know, and just say, hey, I need to plug it into the derivative here. And then I need to see what sign I get for my answer, all right? Okay, so as I was saying here, again, how do you make a determination? Increasing, basically, you'll see a plus. If you get a plus in your last column here, that's increasing over that interval. It's decreasing, you get a minus. Sometimes you could get a constant, which means that you'll have a 0. It may not be positive or negative, which is entirely plausible from the chart we made in step 4. So step 5 here, very simple here. Yeah, very simple. You see net minus, that's going to be decrease on that interval. You see plus, that's going to be increase over that interval. So let's go ahead and take a look and see if we got the right answer for this. All right, so let's go back to our problem here. All right, so So going back to our problem, let's put in our guys. So we're going to put in a 7/2, infinity, here, symbols, there we go, for infinity. And decreasing, we're going to go from negative infinity, symbols again, comma 7/2. All right, and we'll go ahead and put those in, and let's see what we get. Let's hit submit here. Mark a bunch wrong because I don't care. But the 2 that we put in here, that happens to be correct. All right, very good. Would you guys like to try another one? Try another one? You guys want to try another one? If you guys want to try another one, you guys can pick pick the problem I'll do. You guys can pick from 6, 7, or 8 if you guys want me to do another example. 6, 7, 8, or 9, I guess. 6, 7, 8, 9, or yeah, 6, 7, 8, 9. They're both. They're okay. Okay, you guys pick the problem here. I could pick 6 through 11. Let's go 6 through 11. One of those. If you want me to do it. I will do it. 6 through 11. That'll be the next example. Question 9. Okay, let's do question 9. That's fair. All right. Okay, so let's go through question 9 here, just with these numbers, at least in this case. So we're given a function here, g of t. That's going to be equal to 6t over t squared plus 36. All right. So we're trying to find out where we're increasing, decreasing, or being constant. That's what we're trying to do. Let's do these steps in order here. Step 1, we got to find that first derivative. All right, so let's find g prime of t here, at least in terms of the letters. So in this instance, because we have a function divided by another function, we need to do the quotient rule in this case in order to find out what we have here. So we have f and we have g here. So again, the quotient rule here being f prime g minus g prime f over g squared. Okay. So if we put the pieces together here, f prime here is 6. That's the derivative of 6t. G prime here is equal to 2t. That's t squared minus t squared plus 36, pardon me. All right, so let's put those pieces in place. All right, so first and foremost, we have f prime, which is 6 times g, which is t squared plus 36, minus g prime, which is 2t, and times f, which is 6t, all over t squared plus 36 quantity squared. Okay, so now that we have that, we need to clean this up a little bit. Now, normally we don't like simplifying, but because the next step requires us to solve for x, or solve in this case for t, when we set this equal to 0, let's do a little bit of cleanup work here in order to at least make this a bit easier on ourselves to solve for that guy. So let's go ahead and show off exactly how we can do that here in this problem. Hopefully this will make it significantly easier to do. You try it out. Okay, so the way we want to approach this is, let's go ahead and distribute here the 6. We get 6t squared plus 216, okay, minus 2t times 6t is 12t squared. Okay, so this is what we have here in this instance. All over these t squared plus 36 quantity squared. All right. Now we can add up the like terms here. So we're going to get minus 6t squared plus 216 over t squared plus 36 quantity squared. All right. So this is as far as we can go to actually clean this up. Now, the next thing that we do here is we want to set this equal to 0, okay? Now, you're probably saying, ooh, this is going to be pretty tough. And be like, yeah, actually, it's not as bad as you may think. Actually, it's actually rather easy because the ugly part here of the t squared plus 36 quantity squared, and you look at that, that looks a little intimidating. But if we're going to solve for t here, well, essentially, we can wipe out the denominator because essentially what you're doing is you can just like multiply this on both sides, for example. And 0 times anything, as we know very good and well, 0 times anything will just wipe out anything that you have there. So what we have here specifically is we just need to look at the numerator here of negative 6t squared minus negative 6t squared plus 216 is equal to 0. Now we want to solve for t. Let's subtract by 216 on both sides. A little bit of work, but not too much. So here we'll divide by minus 6. And so if we take negative 216 divided by negative 6, we're going to get here, arrow here, this will be t squared is equal to 36. Okay, so we get t squared is equal to 36. We take the square root of both sides. So t here specifically is going to be both our answers here. So plus or minus is in play here. So we're going to have plus 6 and minus 6. Okay, so we're going to get 6 and minus 6 here for our two answers here for t. Before I move forward here, are there any questions about that? Any questions about how I found minus 6 and plus 6, or 6 and minus 6, or what you want to call it? Hopefully that's clear about how we got rid of all the ugliness there. Hopefully that makes a bit more sense now. I'll wait for people to write that down. I think people are writing it down, so I'll wait. Everybody's good? The initial equation here was this, 6t over t squared plus 36, Emma. So I wrote it down up here. This guy. Get the marker going. You're welcome. Any other questions? I'm going to move forward now. If everybody's got that down, hopefully. I'm going to do the next part here. Okay. So that's step that's step number 1 and 2 there. So we got that done. So step number 1 and 2 is done. Now we're gonna move to step 3 here. We're gonna chop up that number line, okay, to make our intervals. So again, to chop up the number line here, we'll go with negative infinity to infinity. We have two values here for t this time at -6 and +6. And all we're going to do is put parentheses around each of these numbers here so we can visually see what our three intervals are going to be. Okay, so there we go. We have our three intervals, as you can see here, and not two for this one because we actually have two answers here for t instead of one. So let's do step 4 here and make our chart. So we have negative infinity to -6, -6 to 6, and 6 to infinity. Now we're just going to go ahead and take a test point here in each of these intervals. So let's take a test point here. So I'll have you guys help me again. Help me out. Pick a value between negative infinity and -6. So a value between negative infinity and -6. What's that going to be? All right, -7. All right, fine. All right, pick a value between -6 and 6. All right, 5. Fair enough. All right, and one last one between 6 and infinity. All right, any value between 6 and infinity. All right, 8. Okay, so here's a question. What do we plug the test points into? So this is a question here for the class. What do we plug the test points into? Yeah, 7 works as well, Nick. True. I know there's a delay, so. What do we plug the test points into? So I want to know the steps here. You guys got to tell me here. So I'll wait until you guys tell me, otherwise I'm not going to move on. So, all right. Very good. So we have to plug it into the first derivative. That's correct. Now, the reason why I asked this specifically here is because this is really, really important. Okay, it's really important that you know that you have to plug it into the derivative here. So again, this is the derivative here of g, in this case, g prime of t or f prime of x, whatever you want to call it, doesn't matter here, but still, the general gist is this is the derivative right here. And we're going to plug in the values into that guy right there. And we're going to see what we get here for plus or minus. And we'll see for increasing, decreasing. Okay. All right, we'll see if it's increasing, decreasing. So there's a good way you can actually do that here. So we do have three values here of -7, 5, and 8. We're going to go ahead and use our calculator here for this. So let's go ahead and do that right now. And we're going to enter this we're going to enter this into the y equals menu. So if you go to your calculator, you have a graphing calculator here, you hit the y equals. You can enter in this function here. Just make sure to put parentheses around around that. So it's a nice little short way you can actually do this out. And we'll divide that by, because the issue, I guess the issue is that you know, it takes a long time to plug in numbers and then see what you get and da 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 da. So okay, so let me change up my window here because I need to put it in. I could put it, if you change up your window here, if you hit second and window, you'll get to this table setup menu here. So put that there, second and window. All right. If you go down and you go down to this one here that says independent, this third option here, and you scroll over to ask and highlight that and hit enter. Basically, in the table, you can ask it to basically put any value into the function that you entered into your calculator. So we're going to quit out of here once you have it on ask, second in mode, and then we'll hit second and graph to go to our table. Oh, so we'll hit second and second graph. Okay. And now all we're going to do here is take each one of these test points, all right, and we're just going to plug them in and see what we get. So the first one here is -7. -7, we get a negative value. All right, then we choose 5. 5, we get a positive value. And then we choose 8. 8, we get a negative value. Okay. All right, so we have that there. Perfect. Okay. So we have a negative value followed by a positive value followed by a negative value. So in this case here, we have our 3 guys here increasing or decreasing here. So the first guy here being negative, that will be decreasing. Second guy here positive, that will be increasing. And then since we got negative for that last one, that will also be decreasing. Okay. All right. Before I move on here, I'm going to enter in the answer into the thing. But any questions about this so far? Any questions? Calculator questions or steps or whatever? Okay. All right. So what we're going to do here next is let's go ahead and enter in our answers here. And if I don't hear any questions, then we'll move forward. Okay, so here we're going to put in our increasing intervals. We'll put our decreasing intervals here. Okay. So we have our 2 increasing, we have 2 decreasing and 1 increasing interval. So let's put in the increasing interval here first. That is going to be from -6 to 6. So that one's here pretty easy to put in. Now, if you want to put in the decreasing intervals here, I'm just going to show you how to do that here. If you haven't done so already, I'll show you here. So we're going to put -infinity. Need the symbols here for infinity. Comma -6. But we also want to, but we also want to put in a second interval. So what you're going to do here is you're going to hit the sets key, and you notice this letter U here. This is going to basically connect this interval with a secondary interval, which is 6 comma infinity. So Put 6, comma, and then symbols, infinity. And let's test it out and see if we got it. All right, submit this. Because again, like I said, we have 2 intervals here. And we got it. There you go. So that confirms our final answer for that one. All right. Hopefully that was pretty okay. Dokes. All right, let's take a good look here at the next one on the handout, I guess I should say. All right. I need to go more time here. All right, so okay, let's take a good look here at talking about numbers 3, 4, and 5 because they are the last 3 questions here on this handout for section 4.1. So I know normally we would take a break here, but I'm going to keep going here, and then after we go ahead and do 3, 4, and 5, we'll go ahead and we'll end off right there. We'll do some examples, of course, with that. So doesn't mean I'm not doing any examples, guys. Yeah. We'll look at some of these problems here for relative max or min. They're not super hard to do. All right. But there are kind of important things that we'll need to keep note of. So let me go back. Okay. So what is a relative minimum, relative maximum? Hey, thanks, Woody. I appreciate that, my friend. Thank you for the compliment. That's really nice of you. All right. So what is relative minimum, relative maximum? All right. So relative minimum here is a point on the graph in which the graph decreases and then increases in an interval. So essentially, what does this actually look like? Well, it's actually not as bad as it may seem. Just go ahead and picture it. Picturing it actually makes this significantly easier. So, and always in the picture, it's always like super easy. So essentially, somewhere on the graph, it's decreasing and then it's increasing. Thank you for the follow, Woody. That's really kind of you, my dude. So again, we decrease and then we increase, and then that relative minimum is sitting right there. Okay, so that's where the relative minimum is. All right. A relative maximum is just the opposite. It's a point on the graph in which the graph is increasing and then decreases inside an interval. We increase, and then after a certain period of time, it decreases. And so there's our relative maximum. Okay. So again, if you understand like what I underline here, decreases then increases or increases then decreases, then finding your relative and relative max is actually fairly simple. If you want to find out the numbers by hand, I didn't spend a ton of time on this, but that's okay. If you want to find out how to do it by hand here, again, what we do need is one more key piece here, and that's talking about a critical number. This critical number here is going to be pretty important, not just for this section, but for the following section. Probably more important than the following section, but still, this is something that we're going to be certainly using. What is a critical number? It's any number in the domain of f of x, in which if you take the derivative of that number, if you evaluate it at the derivative, it's going to equal 0, or f prime of x does not exist. So we have 2 conditions to make a critical value. One, that value is in the domain of f of x, and we put it in the derivative, and somehow it's equal to 0, or it doesn't exist. That can certainly happen because derivatives can physically literally change the function. So there are steps about how to do this here. Okay, so how do we find relative extrema for a continuous function? We find f prime of x, then we go ahead and find the values of which it doesn't exist or equals 0. So pretty much it's the same exact process that we just talked about here, with the extra bit of finding a value that doesn't exist. So maybe you get maybe you get a fraction, maybe one function on top of another after doing the quotient rule. Essentially, it's just including that value there, but the rest of the things are exactly the same. Chopping up the number line here, taking the test points, making our little chart here. Really, the rest of it is exactly the same as we just talked about here in these last two examples. Okay, so nothing is changing. All right, even the plus or minus thing, that's not changing at all. Right, so determining if we have a relative max or min, if we have a relative max, we go from increase to decrease, right? That'll be a relative max, increase, decrease, so plus to minus, or a relative minimum from minus to plus. So if I were to look at this last example, notice we go from decrease from negative infinity to negative 6 to increase. So since we went from decrease to increase at negative 6, that means that in this last example here, x is equal to negative 6. That's the, negative 6 is where we're going to find a uh, relative minimum. So negative 6 would be a relative minimum. Again, we went from decrease. So again, just map it out with your hand and be like decrease to increase. Okay, so that's essentially how I'm doing it out. Just like I'll do these problems like I decrease to increase, and I know I have a relative minimum there. And then notice at 6, we go from, at 6, we go from increase to decrease. So at 6, we go from increase to decrease. So since we go from increase to decrease, that's going to indicate a relative max at that value. Remember, this is the x value here, by the way. So, but you get the general idea about how we can actually find the relative max or relative min based on the same exact thing that we just talked about here. There's only one extra bit, but in reality, the steps are pretty much exactly the same, like literally no difference. All right, but let's go ahead and take a look at some problems here. All right, so problems are kind of important. Let's take a look. Okay. All right. Okay, so let's look at this first one here. So this is a pictorial representation of a graph. We want to find the relative max and relative min. All right. So we want an XY point here because we actually have a graph here. So what is the first relative minimum? They want the smaller of the x values here, meaning it has to be the smaller x. So what is the first relative minimum here on this graph? What do you guys see? The first relative min. What point is the first relative min at least? So just based on looking at that graph there. What do you guys think? Wonder if I can make that bigger. Oh, I guess I can. Oh, maybe I can make the whole window bigger. That might. I can. Okay, that works. Maybe that'll be a bit easier to see. All right, guys, I'm waiting. You guys, let me know. I'll wait. Tell me one of the relative minimums. At -3, okay. All right, so good. It's at -3. In this case here, -3, comma, and the the y value that goes with it, because it wants x comma y. So Nick is correct here. -3, comma 0, right? So Emma, you're correct here. It is indeed at -3. Okay. It's just again they want the y value that goes with it. That's -3, comma 0. I know in the example I showed you here it was -6. That would be x is equal to -6, and we'd find its corresponding y value by plugging it into the original function. But in any case, -3, comma 0, at least according to this picture, is the first one. All right, very good. What is the second relative minimum at? All right, so what value is the second relative minimum at, according to this guy? All right, that's correct. 3 comma 0. Good. All right, Lee Wen, that's correct. Very good. Okay. All right, so far so good. We found the both relative minimums. Let's try and find the relative maximum. What's the relative maximum here? What point is the relative maximum at? Okay, nice job. That's right. 0 comma 9. Nice. Okay, very good. All right, and if we try this out here, let me go ahead and just hit the submit key for the sake of showing that off. All right, and as you see here, we got those correct. All right, good. Let's try the next one. Okay, let's just take a look at the next one here. Okay, all right, this time here, this is our graph. Can anybody tell me here what is our relative minimum and what is our relative maximum at? Get a relative minimum and a relative maximum. Let's take a look at the relative minimum part here first for this graph. Where's the relative minimum at? What's the relative minimum? What point is that at? -2 comma 0. Okay, good. That's right. All right, so we have -2 comma 0 here. That's where that relative minimum is located. All right. How about the relative maximum here? Okay. How about the relative maximum here? What is the relative maximum for this? Relative maximum. Is there a relative maximum for this problem? Let's see. 0 comma 4. Okay. Now in this case here, that's a good guess there, Lee Wen. But Nick has the right of it here. That's going to be does not exist. Now let me explain why it's not 0 comma 4. Because remember how it works for relative maximum. It has to be increasing and then decreasing, all right, in order for it to qualify as a relative max. The problem here is that this graph here increases and then at 0 comma 4 increases again. So it doesn't decrease, it just increases again. It goes from increase to increase. So because of that fact, it does not exist is the correct answer for the relative max for that one. Okay, so just submit that really fast. And there we go. All right, sorry, passed it up. Okay, so that should explain that one. All right, let's do one more here together. Here's a function. I need to make this smaller to get the window in there. There we go. Okay, so we want a relative minimum and we want a relative maximum. So what is the relative minimum here? Relative minimum for this? All right, see if anybody gets it here. Relative minimum. This one here is not so bad. Just have to carefully look at the graph. All right, 3,9/2, that's correct, right? It decreases and then it increases. We have 3,9/2. All right. About the relative max. All right, -3, -9/2. Nice. All right, good. All right, good. Let's check it out. I think that's how we should write that one. Yeah, okay, that's good. All right. Okay, and that is going to be that. All right. All right, and that is section 4.1 in a nutshell. Good stuff. Any questions about section 4.1? Any questions at all? Hopefully that was pretty. All right, so let me get your opinion here, really quick. Let me ask this. Let me ask this for everybody here, and just type a simple yes or no or whatever your opinion is. If you want to add more, was this easier to follow today because of using the homework questions? Want to be sure that at least it was a little bit more clear. But okay. Yes. Okay. All right. That's fair. All right. All right. I wanted to get your personal opinion about that, and I wanted to be sure that it was clear that you guys had the right of it. So, all right. All right, no problem. All right, so we're going to do homework example questions from now on. All right, so hopefully this will make this process here, because again, people had a lot of confusion and stuff. So, okay, hopefully this will clear up a lot of that confusion that we had from previous sections, and hopefully this will make it a little bit better. So, okay, good. That works. All right, so we'll do that from now on here until the end of the semester. I like the feedback you guys are giving me in that regard, because this is like This is like me kind of adjusting with you guys. It's like, okay, I could feel the frustration a bit, and I'm like, well, I gotta change it up somehow. So this is gonna work out just fine. Okay. All right. So that'll take care of it for today, everybody. All right. I want to thank you all for first of all, I want to thank you all for coming out here to the stream today. All right. All of you are wonderful. Thank you so much for the feedback, everybody. You guys are absolute legends. Thank you so very much. Hopefully this will promote an even more positive experience for the class for the remaining time. So again, as always, feel free to go ahead and contact me via Discord or contact me via email. I'll go ahead and answer your questions there. All right. Thank you so very much here for today, everybody. We will see you all tomorrow. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right. I'm gonna stick around here for a little bit with Lee Wen, but take care of yourselves, everybody who's out of here. We will see you tomorrow here. Have a great one, everyone. Take care. Bye, everybody. Woo, bye. All right. Lee Wen, you wanted to show off on the calculator, right? Hello. All right, let me take a look at your let me look at your thing there. All right, so I'm gonna look at your example that you sent to me here, and I'll show you on the calculator. Where is it? Question. It's not on here. Okay, so not this. Not this. I got like a lot of windows open, so there it is. Okay. Okay, so I have to look really carefully at this. Okay, so I see, like, for example, I'll do a quick one here. So for example, on the example you gave me, you have like 650x minus 0.9x squared, okay? And you were asked, hey, can you tell me what curve is going to match that, you know, amongst the 4 curves that you had there, all right? So let's go ahead and met that out. Come on. 3.4, question 7. Okay, yeah. It's I'm looking at your specific one, yeah. Well, it's so hard to look at that. All right. Trying to make it super big. I'm trying to make it big so I can read it. It's not your fault, it's just how the screenshot is. It is hard for me to read. Alright, let me read that again. 650x minus 0.9x squared. Okay, so what I want you to do here, Lee Wen, is to go ahead and go to your calculator here. Okay? Hey, I have bad eyesight, I ain't gonna lie. So on your calculator here, Lee Wen, I want you to go ahead and hit the... Stop that music for a second. I want you to go ahead and hit the Y equals key here. All right. And I want you to get to this menu right here. Okay. So what we're going to do here specifically is we're going to enter in one of those functions here, which is going to be, let's do the revenue function. So 650x minus 0.9x squared. So 650x minus 0.9x squared. So This part here, I'm pretty sure you know how to do pretty easily. So let's put it on a graph here. Okay. So that graph, not the greatest graph that I've ever done in my life, but it is what it is. Okay. Now, the way we can kind of get the graph here to work out is we're going to do a zoom here. And so it doesn't look very good because it's just a line, but we're going to go ahead and do number 0 here. We're going to start off with that, is to do zoom fit. Okay, so hit the zoom key, go to number 0, which says zoom fit. We're going to see what we can get here with this when I actually hit enter on this. Okay, so do I actually have it? Should it look? Okay, yeah, that's fine. Fine. Yeah, look at the graph here. All right, now if zoom fit doesn't work out so well, we can try other things. We can say zoom quadrant 1, for example. That's another way to kind of look at it. I guess that doesn't really help at all. All right, I'm gonna try and get it to the B needs to. Let's go to zoom fit here. All right, let's zoom out. See if we can get it to zoom out. Why is this a line? Oh, there we go. Okay, we're gonna keep zooming out here. All right, there we go. We're starting to see what it is here. So this is the graph here. If we keep zooming out from the center here, you can see what the graph is going to be like. All right, it's going to be a pretty big parabola, but again, you can see that how that's going to work out. So if I looked on the graphs there for this, notice it kind of goes slightly above the x-axis, and it goes then it kind of goes back down. So looks like here, let's go ahead and trace this out. It's probably a bit. So does it go through the point here, 69? All right. So it looks to me like the graph that probably best reflects this is probably that third graph you see there from the screenshot you sent me. It kind of goes up above the x-axis and then kind of dips down below if this is your revenue function here in this case. So we play around a little bit here in this case. So the third graph here in this case that you sent me on the screenshot would be the one that you need to choose for the revenue function graph. Okay. Again, it goes a little bit above and then it goes a little bit below. And there you go. That is going to be your winner, at least for the revenue one. We haven't looked at the other two yet, but that's for the revenue one. Does that make sense? So we're just going to play around with the zoom here in order to get the bigger picture. Because sometimes it takes a little bit of zooming out in order to see what that. You didn't get the same graph? Okay. Make sure you enter this in properly. Okay, 650x minus 0.09x squared. Your graph probably looks really, really strange. Okay. So, all right, Lee Wen, you want to follow me here for just a moment? Okay. So, what would? Okay. Okay. If you could do me a solid. All right, Lee Wen, can you do me a solid and hop on the Discord there? I just wanna be able to talk to you back and forth, if that's okay. Because then it's easier for me to kind of go back and forth with what you're doing on the calculator. If you're okay with that. Okay. I'll give you a second and then just go ahead and join a voice channel there. Or actually, hello. Uh, all right. Let me give you a. Let me call you then. That'll be. Hello.
Hi.
Hello. How you doing?
Good.
Good. Okay. So you have your calculator in front of you, right? And you did enter in the function as you said, right? Everything's cool there,
Yeah.
right? Okay, perfect.
Uh-huh.
Okay, so I'm going to start off from the very beginning here. You probably have a graph that kind of looks like this, right? Like if
Did I should I open the other screen? I mean,
your
you
screen.
usually
Yeah,
yeah.
go ahead and open up your screen so I can see what you're doing on your Oh wait. Well,
Huh?
I don't know what you're doing on your calculator unless it's a handheld calculator, unless you're doing it online.
Wait a minute.
Okay. I will wait a second. So,
I need to open the Twitch.
no, you're fine. You're fine. You can you see Twitch?
Oh,
Yeah, it's not on the stream there. It's on the. I can shut down Twitch and I can put it up on the screen there if you want. Or actually, I could do both. Can't I?
so,
Technically.
because I kind of confused. I need to open the Discord and Twitch off
Okay. Oh, okay. I see what
on
you're saying.
my yeah.
Yeah. All right. Here, can you see the screen
Oh,
now? Okay.
yep.
Yeah,
Better.
I'm broadcasting on Twitch, but I can share the Twitch screen with you, so that's not a problem.
Okay.
Okay,
Uh,
but do you have a graph that looks like this, right?
uh,
I don't know if you do, but I'm just saying.
no.
No? Okay.
Mm-hmm.
Now, your graph may look a little strange like this, but that's okay. So what I would like you to do is hit the zoom key, and then
And
zoom out. Just zoom
yep.
out.
Mm-hmm.
And then it'll zoom out, and then keep hitting enter until it zooms out to an appropriate length. Now, you'll notice that it starts changing a bit the more you start zooming out. Oh, I guess I'll need to fit in the quadrant. Let me see if that works.
Zoom.
I'm so bad with it. I gotta learn to be better. every
It's
every
hard.
Yeah, I know. Every time I try and do this appropriately. All right. Okay. Try this. Let's try this. Okay. Let's try it from the
Okay.
beginning here. All right. I want you to hit the zoom key. Go down
Zoom
to
key.
zoom key. Go down to zoom fit. That's number.
Zoom fit.
That's number
Okay.
0, and then hit enter. And it should look maybe like this. Maybe.
Yeah.
Okay.
Mine's
And,
the same yours.
okay. Good. Let's try and zoom out from there, and let's see what
Yeah.
we get. So zoom out. Yes, okay, good. And let's zoom out again. And let's zoom out again. Let's zoom out again.
Uh-huh.
And let's zoom out again. And you know, now you see the graph, right? Now you're starting to see it's a big old
So
parabola.
we just press the enter again and again, right?
Yeah, yeah, for zooming out. That's right. So did you get that?
Mm, almost.
Oh yeah, you may have to enter it in a few times before you get it to look like what I have on the
Yeah.
screen. Okay.
Send yours.
All right. And then you could zoom out once again, and you could see like what the general graph looks like here. Again, it's going to match the one that looks like the third graph that you have on the screenshot
Yeah.
for your revenue function. So that's the one that you want to choose. Okay.
Oh, gotcha.
All right.
Okay. I think the other question I can try do again.
Yeah, so you may need to play around with the zooms a bit in order to make it fit, but just try zoom fit first and then zoom in or out, in order to get the general shape of the graph on the calculator. And then one of them is going to match one of the 4 that you have there from the screenshot that you sent me, okay?
Okay. Thank you so much.
Okay, no problem. All right.
Thank you.
You have a wonderful night and we'll see you tomorrow, okay?
Okay. See you.
All right, take care.
Bye.
Bye. All right. All right, everybody. Thank you so much. All right. Everybody, take care of yourselves, everybody. We'll see you tomorrow. Have yourself a wonderful day, everybody. Take care. Bye.